All right, ideas on what we can do to figure this out. What kind of triangle? A right triangle, which means dropping a perpendicular from our point down to the x-axis to create our right triangle. Okay, well that's pretty, but now what?
Use the sides to find the angle. I don't know how to describe what it is. If yes. Okay, so everyone's pointing there. Oh, okay. I get the pen. So we know that this distance is 4. This distance is 9. So we can use one of these. Is it -4?
Yeah, it is
I don't understand how you get on negative. But okay.
The distance is 4.
The
The point
distance
is 4,
is
but the
4.
distance is 4.
Aw. You can use that either of those. I think find this angle, or maybe both of those. Find that angle, and then that angle you do 180 minus whatever we get to get theta.
Okay. Now,
And then
my
what
question
from
is, do I need to know theta?
there? Okay, never mind.
No. Okay.
I
Because
tried.
when I am trying to find the trig functions, if I'm already looking at a situation where I can set up the right angle, all I need are the ratios of sides. Okay, it doesn't really matter what the angle actually is. Okay, so I don't really need this part of it. Okay, but the other part is helpful. So distance-wise, it is a distance of 4. However, because of the direction we had to go to get that 4, I do want you to consider it as negative for the moment. Okay? Our other leg is going to be 9. So what is the other piece that we need? The hypotenuse. How are we going to find that? Pythagorean. So Pythagorean would be -4 squared plus 9 squared would have to equal c squared. 97 equals c squared, so c is going to have to be root 97. Okay, now I have everything that I need to be able to set up the trig functions. So, what's the sine of theta going to be? Now, here's the, I heard somebody kind of mention it, but here's kind of the cool thing about trig. The angle that I'm actually asking about is this one, right? I started here at our positive x-axis, I rotated in the counterclockwise direction, ended up with this as my terminal. This is the angle that I created with that. But the angle I'm actually using inside of the right triangle to come up with my ratios is actually this one. Okay? But this is what we would call a reference angle to this one. A reference angle is always an angle that's created by the, sorry, I keep missing an important word. A reference angle is always the acute angle that is created by the terminal side and the x-axis. So let me say it one more time and hopefully I'll get it correct. The reference angle is always the acute angle that is created by the terminal side and the x-axis. Okay? And so whatever sine function, cosine function, whatever trig functions I get for my reference angle are the same trig functions I get for the original angle that I was interested in the first place. Okay?
Wait, you said they're the same or?
Yes,
So like.
at least number-wise. Now, that you can argue about positive, negative, and we'll talk about that in a second. But in terms of finding the trig functions for this angle, I'm really going to do that by finding the trig functions for this angle. And the answers I get for this angle are the answers I would get for that angle.
Wow. Just works.
Yep, this works.
Why? Why does that?
Where's the triangle?
Why does that?
Because ask me that at the end of class,
Okay.
okay? I think we will have gone through enough by the end of class, I can answer it better. To try to answer it right now is gonna be just jumping ahead too much, too fast, and it's gonna be confusing.
Okay.
So
Why does that work?
Why does this work?
can you use
ask
that?
me at the end of class why this works, okay? And I'll tie it all back up in a nice pretty bow for you, okay? All right, so for the moment, we're just taking it on faith that Mrs. Gordon knows what she's talking about, and if I find the trig functions for this angle, they are the same as the trig functions for that angle, okay? So, the sine of theta is going to be what?
9 over.
9 times 9 square root of 97.
Okay, so if we just go with opposite over hypotenuse, we get this. But then we need to simplify that because we can't have radicals in the denominator. So our final answer should look like this. Everyone comfortable with rationalizing?
Yeah.
Getting that radical out? Okay. Cosine.
4.
Yeah, 4 over.
Yeah, we're going to keep that negative with it, remember? So negative 4 times the square root of 97 over 97, because the same thing would happen. We'd end up with something like this, so we got to fix it. How about tangent?
9 over.
9 over negative 4. Cosecant.
97 over 9.
Secant.
97. Negative.
And cotangent.
Wait, so we are taking the negative?
Yep. We're keeping the negative in there. So I know that's weird because we're labeling the side of a triangle to get it, but I think it'll make a little bit more sense about why we're keeping it negative in just a second. Okay, everybody good with those trig functions? Does that, all those make sense? Everybody understands where we're getting those from, yeah? All right, so based on this, let's try to do a little bit of generalizing here. In the situation where you are given an ordered pair of a point on a terminal side, can we come up with sort of a general rule of thumb about how to figure out sine, cosine, tangent, and then the reciprocals of that? Okay? So the first thing we need to understand is that our angle here was still being created by rotating. Starting here in standard position and rotating around to this point. So imagine for just a second that the point here that we're using on the terminal side, imagine that that point has a little paint roller underneath it. Okay, kind of like the workers out on the field before we had turf, if you've ever watched them out the windows up here, trying to make their circles and, you know, with their little paint roller. Okay, so imagine for a second that this dot had a little paint roller underneath. So that means that, pick a color here. That means that that dot being square root of 97 away, it's almost 10. So that dot was right about there when we started.
Yep.
Okay?
Mhm.
And then as it rotated, and I'm not very good at this, so don't laugh at my circle. It helps that it's dotted. It looks a little better if I'm actually trying to draw it. They don't come out very good. All right. But as it rotates around, it starts drawing this circle, right? And if it would continue to rotate around, it would continue to draw this circle. Which means that not only is this distance the hypotenuse of this little triangle that I just created, it's also what?
Radius.
The radius. So oftentimes in these situations, this distance right here is referred to as r. Even though we're kind of getting it because it's the hypotenuse of the triangle that we created, it also ends up being the radius of this circle that would be drawn if you sort of trace to that point around. So they tend to call it r. And because that distance for r is the distance from the point 0, 0 to the point whatever that is, some xy combination, we can get r simply by taking the square root of x squared plus y squared. Because if you think of the distance formula that we get from Pythagorean, it's always x1 minus x2 squared, y1 plus y1 minus y2 squared. Well, one of my points is 0, 0. Right? So we ultimately just end up with x being squared, y being squared, add those two together, square root. Which, if you look, is exactly what we did. There's my x value being squared, there's my y value being squared, and ultimately I had to take the square root of it to get my distance. Okay? Alright, so going back to this then. When you look at the sine of our theta, where did that 9 come from? The y. Where did that square root of 97 come from? The r. So in general, sine of theta is going to be found by taking the y coordinate of the point and dividing it by the r value that you would find. The room just got brighter, John just got this. The look on his face was like, okay, what about cosine?
X over R.
It's x over r, because now it's the negative 4 over the r, which is what we use to fix to get this, right? So that's going to be x over r. What about tangent?
Y over
Y over x. And then the other three are just the reciprocals. So this is going to be r over y, r over x, and x over y. So what this means is if I give you the same type of problem where I tell you, here's the ordered pair of a certain point that's on the terminal side, you don't necessarily have to draw it all out. Find your r value by taking the square root of x squared plus y squared from your ordered pair, and then set up ratios. Now, if you forget this, you can still always go to the default of I'm going to draw it out and make my triangle and figure it out from there. But you don't have to, because generally this is how you would set up the ratios for all of your trig functions as soon as you figure out r.
So why generally not always? Like this.
I meant generally more in the, it doesn't matter what your points are. In general, this is how you do it. I didn't mean it as in there's exceptions. Okay? Now, the other thing that I want you to notice when we do the trig functions on something like this is the fact that some of our trig functions now ended up negative. We didn't have that with right triangles. When we were just dealing with acute angles in our right triangles, our answers were always positive. But now we've got these situations where some of them turned out negative, which is why I wanted to keep this as a negative value, showing that we were going to the left, because it now shows us that sometimes we get negative stuff for our trig functions. Okay? So, Let's make sure we understand what's going on when. If I figure out r, is r going to be positive or negative? Always? Yeah, because you take x and square it, you take y and square it, so regardless of whether they're positive or negative, when I square it, it's going to be positive. And then when I take the square root of it, again, because we're dealing with distances, it's always going to be positive. So r is always going to be positive. Okay? Sine is related now with y over r. Cosine comes from x over r, and tangent comes from y over x. So if we think about this in terms of our quadrants, and everybody's good with this, right? Everyone knows this is the way we label them? 1, 2, 3, 4. Okay? So in the first quadrant, are my x coordinates going to be positive or negative? Positive. Are my y coordinates going to be positive or negative? Positive. Okay? So, sine then is going to have to be what? Positive or negative? Positive. Cosine is going to have to be, and tangent is going to have to be, right? Because all of our x's and y's are positive, so everything we get from it will be positive. Okay? Second quadrant. X coordinates, negative. Y coordinates, positive. So sine is going to be positive, because y over r, positive over positive. Cosine is going to be negative, because that negative x over positive r now is going to give me a negative answer. And then my tangent, also negative, because the positive y over the negative x is going to give me a negative answer. Okay? Third quadrant, x coordinates, negative. Y coordinates, negative. So sine, negative. Cosine, tangent, positive, because now it's actually a negative over a negative when I take y over x, and so that actually ends up giving me a positive. Okay? And then in the fourth quadrant, x coordinates, y coordinates, so sine is going to be cosine, tangent, okay? So, for those of you who like little tricks on helping you remember things, here's a little trick for you. Oh, there we go. I've also heard it with calculus, so whether you prefer Chinese or calculus, you can do whichever you want. Okay, so why does this help? All means all of my trig functions in the first quadrant are positive. In the second quadrant, which one's positive? Sine. S. Third quadrant, which one's positive? Tangent. T.
Oh, that's really good.
Fourth quadrant, which one's positive? Cosine. So your saying helps you remember which one is positive in which quadrant, and then the other two have to be negative. And then the other three, the weird ones, cosecant, secant, cotangent, they're going to keep the same sign as what their reciprocal's of, because taking the reciprocal doesn't change positive or negative. So if sine was positive, then cosecant would have to be positive. If tangent was negative, then cotangent would have to be negative. Okay, they keep the same sign. Okay, make sense? So sometimes you're asked to figure out what quadrant are you talking about based on a little bit of information. If you'll notice here, I'm giving you two pieces in each problem. Here I'm telling you the cosecant of theta has to be greater than 0, positive, but I also want the tangent of theta to be less than 0, negative. Now if I only gave you that, which quadrant would we be talking about?
1 or 2.
1 or 2. So usually just one piece of information is not enough to really narrow it down. Okay? We usually need two pieces. And if I have two pieces of information about different trig functions, I should be able to narrow it down to a single quadrant that we're talking about. So if I want cosecant to be positive and tangent negative, then what am I talking about?
2.
Number 2. Because cosecant is just going to be the same as sine. Sine is positive, tangent's negative. We're talking about quadrant 2. Now I can narrow it down to just 1. Okay? What if I want the sine to be negative and the secant to be negative?
3.
3, because secant is going to have the same sign as cosine, so sine and cosine are both negative in quadrant 3. Okay? All right, so with that in mind, try that one. So what's something you automatically know from the information you're given?
The sign.
Sine is going to have to be what?
1/2.
1/2. We're given cosecant is 2. That must mean sine had to be 1/2, because we know they're reciprocals of each other. Okay? What else do we kind of automatically, is that? What else do we automatically know given both pieces of information?
It's quadrant 1.
We're in quadrant 1. Because I'm being given a cosecant that is a positive answer, and I'm being told the tangent had to be positive. So we know we're dealing with quadrant 1, which tells us all of my answers are going to end up positive. Okay? So, how do I find the rest of them? How do I find cosine, for example?
Use what you know about sine. You know that one side is 1 and the hypotenuse is 2. So
So
you
you-
could do 2 squared minus 1 squared equals a, which makes the other side the square root of 3.
Okay, so you could do it that way. Think about it in terms of the right triangle again. 1/2 being opposite over hypotenuse, set that up, figure out your third side, and then set up the rest from there. Anyone try it a different way? Okay, you could also just go back to the fact that we said sine was equal to y over r. And we said r was equal to the square root of x squared plus y. squared, which ultimately is kind of the same thing as what we did up here, but just a little bit different perspective. We would put the 2 in as r. We'd put in 1 as one of the sides and then figure out the other side, and then go back up here and figure out, okay, so what would have to work? You could do it that way. There's also something which your book points out that I've chosen not to emphasize right now because we're going to see it again in chapter 5. So I'd rather talk about it more in chapter 5, but I'll just show you quick that this is another way you could do it. And that is what's called an identity. Probably one you're going to be familiar with because of all the identities. This is probably like the one to remember. And it's the one that says sine squared plus cosine squared has to equal 1.
Yeah.
Right? So I could put my sine in, say, all right, well that means that 1/2 squared plus whatever cosine squared is going to be has to equal 1. Well, that makes this 1/4. So cosine squared would have to equal 3/4. And then if I take the square root, plus or minus the square root of 3/4, that means square root of 3 over 2. But in the first quadrant, do I want the plus or the minus? Plus. That's another way you could do it. Okay, so there are different ways to get to this answer. In the homework, I'm pretty sure there's one set of directions. Well, actually, I'm not sure. I may not have assigned that. If you get to a set of directions that say you have to do it by using a trig identity, ignore that and do it whatever way makes sense to you. You could use the identity. You could just set it up with a triangle. Whatever makes sense. I don't care which one you do. All right, so that means cosine is going to be square root of 3 over 2. What's our tangent going to be?
3 over 3.
Secant
2 square root of 3 over 3.
and cotangent. And in the first quadrant, they're all negative. Or all positive, excuse me. Now, what if I had changed one little thing here and said, nope, I want cosecant to be 2, but I want tangent to be less than 0. Then what quadrant are we talking about?
Oh yeah, 2 to 2.
Quadrant 2, right? So if this became quadrant 2, how would that change any of these answers? Or would it?
Cosine and tangent and then secant and cotangent and be negative.
Okay, so in quadrant 2, the only one that is positive out of the top 3 is sine. So that means cosine and tangent would have to be negative, which then means their reciprocals would have to be negative. So the number parts don't change, but whether they're positive or negative is going to change based on which quadrant you're talking about. Okay? Okay, so we've got this sort of general setup now. We can figure things out based on our ratios of y over r and x over r and y over x and all of that. If we know a particular point on the terminal side, and we can figure things out. So we've been able to generalize that to work for anything. But let's make that even just a little bit more sleek. And let's say that instead of just being any circle that gets created, that we end up making a unit circle. Anybody remember what it means to be a unit circle? Sam?
Radius of 1.
Radius is 1. So if we're talking unit circle, we're talking about a circle where the radius is always 1. Okay? So if that's true, what's going to happen to these ratios if I now make the radius 1?
Oh.
Sine becomes
Y.
y. Cosine becomes
X.
x. Tangent becomes
Y over X.
same thing because there's no r in it, right? But it makes those ratios even more streamlined. Now we're saying that if this is happening on a unit circle, so the circle that was created by this point gives me a radius of 1, then whatever my y coordinate is what the sine of my angle is. Whatever my x coordinate is what the cosine of my angle is. Plain and simple. And then tangent is still whatever y over x would be. Okay? And then our other three are still just going to be the reciprocals of that. So you get that. Okay? So, if we're looking at a unit circle, drag this up a little bit. There we go. Looking at a unit circle, you have them, oh, maybe you don't have them so much. I know some of you took one of these papers yesterday. Does anybody need one of these? I might need to make some more copies quick. One of these that has the unit circle on one side.
Oh wait, we got those. Wait, I didn't take it, right? Are we supposed to take them?
Some people did yesterday, but
Are we supposed to take them?
I wasn't sure if everybody got one. Okay, I'm gonna need to go make a few more copies. So here's what I want you to do. Based on what we just talked about, okay? Let's say that this outside is the circle that we're gonna say has a radius of 1. Okay, this is my unit circle. And we're saying that that circle was created by a point right here on the side of my angle. Okay? So when it's right here, obviously we're at a 0-degree angle. As it rotates around, we get other measurements. And what I want you to write down while I go make these copies is, what would be the sine and the cosine of 0, 90, 180, and 270 based on what we just talked about? Okay, sine and cosine of 0, 90, 180, and 270 based on what we just talked about. I'll be right back.
Zero.
Cosine. It's
I know.
no, it's 1, 0, 0. Cosine is -1, 0. Tangent of 90.
Yeah.
Oh, this would be,
A 1. Yeah.
Yeah.
yeah, or no, 0.
Undefined. Or just or no.
Sine, yeah, so. I'm putting it in notation, you know, when I put it in. And then the next one would be cosine.
What's next? 270?
Zero.
It's too easy.
Where are you finding tangent?
Yeah, I'm putting down tangent, so tangent is sine over cosine. So it's just 2 answers in one, it's less writing.
Wait, 35 cosecant and stuff like that too?
No, it's just sine cosine.
0, 1, and
Cosine,
0.
what do you mean now?
For what?
Sine is 0, cosine is 1, tangent 0.
Yep. Or, yeah. I don't think tangent is necessary. I just find tangent and I don't simplify it. So like 0 over 1, I just wrote 0 over 1 because that's sine and cosine. 0.
Oh, wait, yeah, because I.
Well, yeah, I don't simplify it so that I can
Let's
Cosine
define
would be
0 because it's not one
root
first.
2 over 2. Or root 4 over 2. Mine's two.
Ah, yeah.
The cookies dissipate to the cookie gods.
You divide by 4 cookies by it just doesn't work.
Sine of 0
So how
How many cookies did each person get? Actually, don't exist. They don't exist, so they don't get any.
But you know how for if you have like 4 0 cookies among 4
sorry.
you know how you can solve a 0 divided by something? And you have 0 cookies among 4 cookies, you get 0. So no cookie. But can't have it the other way around.
I don't know, whatever.
You see how
I stopped
confused
listening and I kinda got confused and tired. Oh wait, I already have one. Actually,
All right.
this.
So, what is the ordered pair of this point right here?
1, 0.
1 comma 0. So what is the sine of that angle?
0.
What is the cosine of that angle?
1.
Right? My x coordinate gives me cosine, my y coordinate gives me sine. Boom. End of story. So, on the table that's on the back side of your unit circle, go ahead and fill in for 0 degrees that we get a sine of 0 and a cosine of 1. Okay? All right, then we start rotating, and we rotate up to an angle of 90 degrees. So now my point's right here. What is the ordered pair of that point? So what's my sine? What's my cosine? So put those in. Okay, we keep rotating, and now we're over here at 180 degrees. So now the point's right here. What is the ordered pair of that point? What is it? -1, 0. So the sine of 180, 0. The cosine of 180, -1. So fill those in. 180, 0, -1. Okay, and then we keep rotating, and now we're down here at 270. The point now is right here. Ordered pair for that point. So the sine of 270
-1.
and the cosine of 270.
0.
Oh, stop. I'm not ready for that yet. -1, 0. Okay? All right, so now that I know sines and cosines, which came from y's and x's, what is the tangent of 0 degrees? 0, because it'd be 0 over 1. What is the tangent of 90 degrees?
Undefined.
Undefined, because it would be 1 over 0. What is the tangent of 180 degrees?
0.
0. What is the tangent of 270 degrees? Undefined. Okay. Now, what is cosecant of 0? Undefined. Because the reciprocal of 0 is going to be undefined. How about secant?
0. Oh, we're just kidding. I was going on to the next one.
1 over.
I was being a robot.
1.
1.
Still.
Reciprocal of 1? 1. What is the cotangent?
Undefined.
Undefined. Okay, so for these bottom 3, we're just taking the reciprocals of the top 3. All right, for 90, cosecant,
1.
secant,
Undefined.
cotangent,
0.
I agree with those statements.
0. The reciprocal of undefined is not necessarily undefined. you have to think about why we made this one undefined, because it was 1 over 0, and then when I flip that, making it 0 over 1 is now okay. So that's going to give me a 0. Okay? 180. Cosecant,
Undefined.
secant,
-1.
cotangent.
Undefined.
And 270,
-1. Undefined. 0.
and then we've got 360 out here, but 360 is really just the same as what?
0.
As 0. So 0, 1, 0, undefined, 1, undefined. Okay? So that's what happens on the axes. Okay? And you'll notice that the first row across is asking you which quadrant you're in. Well, for these, you're not in a quadrant. You are on an axis. So the best way to label these is based on which axis you're on. So for 0, we're on the positive x-axis. For 90, we're on the positive y-axis. 180, we're on the negative x-axis. 270, we're on the negative y-axis. Okay, and then 360, we're back up to positive x. So now it's the 3 angles that happen in between those that are within certain quadrants. So obviously 30, 45, and 60 are in 1. 120, 135, and 150 are in 2. 210, 225, and 240.
3.
And 300, 315, and 330.
4.
Okay? Now, I want you to take a minute and fill in the positive radian row. What are the radian equivalents to all of those degree measures? So, should be able to do this quickly. Some of you have figured it out. The angles that you have here on the table, these are what's called the special angles on the unit circle. That's also what's on your unit circle, but as radians.
What?
So if you just start at 0 and follow your special angles around the circle, that's what these degrees are. So all you have to do is just copy in order what your radian special angles are underneath your degree special angles, starting with 0 being 0, and you'll have all the equivalents. radian should look like. Now, for the next 15 seconds, I need to try to convince you that radians are your friends. Stop moaning and groaning about radians. There are people who like, oh, but I like degrees, I understand degrees, why do we have to do radians? Trust me, in this context, radians are going to make life much easier. Because start looking at your radian measures for these special angles. There's a whole lot of pattern stuff going on in there. And if you can start understanding the patterns, it makes what you have to know easier. And you will have to know this entire chart when we're all said and done. And you have to know it quickly. You have to be able to come up with any trig function for any one of these 16 angles like that. Now, there are some of you who are keeners, and you will take, what we got, 16 times 6, 96 different little spots here, and you're going to sit down and you're going to memorize all 96, and God bless you for it. But honestly, that's silly.
Mr. Schreitman told us that during the whole trig unit, the thing he doesn't want us to do is memorize.
So you have to memorize a little bit, but you don't have to memorize all 96. Okay? So I'm going to convince you by the time we're done that you only have to memorize 10. And if you memorize 10, you can figure out anything else. But part of that is understanding how the pattern of the angles go so that you can start using that with your trig functions, because there's going to be patterns that come up with your trig functions as well. So looking at your denominator, 6, 4, 3, 2, 3, 4, 6. 6, 4, 3, 2, 3, 4, 6. Noticing that the only denominators we ever get are 6, 4, 3, and 2. That there's a pattern to how they go around the circle. Noticing things like in the second quadrant, we're all just not quite to pi yet. Right? 2 pi over 3, 3 pi over 4, 5 pi over 6. Well, pi would be 3 over 3, 4 over 4, 5 over, or 6 over 6. Right? So in the second quadrant, we're at that point where we're not quite there yet. So it's all 1 less than the denominator. Then once we get past pi and we're into the third quadrant, now since we're a little bit beyond pi, all of our numerators are 1 more than the denominator. And then when we get over here into the fourth quadrant, since 2 pi is going to be like 12 pi over 6 or 8 pi over 4, all of these are just 1 less than that double because we're not quite to 2 pi yet. Okay? So recognizing that kind of pattern can help you with, oh, it's 3 pi over 4? Okay, that's second quadrant. Oh, I'm dealing with 11 pi over 6? Okay, that's fourth quadrant. Knowing which quadrant we're talking about. Okay? All right, so when it comes to being asked to find the trig function for an angle, some of you may have seen this, but for those of you who have, just let me explain it once for those who have not, okay? And then I'll let you play around with it and figure some stuff out. So this problem is asking you to evaluate sine, cosine, and tangent for the angle 2 pi over 3. Okay? There are 2 parts to this problem. One part is to figure out what my number should be, and the other part is to figure out whether it's going to be positive or negative. The number part is going to depend on my reference angle. The positive negative part is going to depend on which quadrant I'm in. As we said, the reference angle is the acute angle that we create with our terminal side and our x-axis. Okay? So, if we just think about this for a second, if I'm talking about 2 pi over 3, which quadrant am I in? 2. Okay, so it's something over here. So this is the 2 pi over 3 I'm interested in. But this is my reference angle. How much is my reference angle? Really? You're going to shift into degrees? Is there not enough radian going on up here?
Pi minus 2 pi over 3.
Which is
Pi over 3.
pi over 3. 2 pi over 3 has a reference angle of pi over 3. If I asked you to find 7 pi over 4, what would you guess your reference angle is?
Pi over 4.
Pi over 4. If I wanted you to find 5 pi over 6, what are you going to guess your reference angle is?
Pi over 6.
Isn't that easy?
Oh.
Your reference angle is always the first quadrant angle with the same denominator. So let's talk about pi over 3 for a second. Okay? Now, maybe you're all keen and you've memorized what pi over 3 is. Quite frankly, I haven't done that for 2 years now because I figured out this left-hand trick last year. 47 years. Where was this? But last year I was looking for something else for the online class I was doing, and I stumbled upon this YouTube video talking about this left-hand trick, and I just about fell out of my chair because I literally was like, where has this been in my whole life? So here's how it works. Your left hand, you're looking at the palm of your left hand. Okay, so I'm going to hold it out here like this so that it's your perspective. All right? Imagine that your pinky represents the x-axis and your thumb represents the y-axis. Okay? So that means that your pinky represents 0 radians and your thumb represents pi over 2. So your hand is creating the first quadrant. Okay? From 0 to pi over 2. Which means that these 3 fingers represent which special angles in the first quadrant?
60, 45,
Or radians.
Pi over 3, pi over 4, pi over 6.
Pi over 3, pi over 4, and pi over 6.
Oh, the dangerous game here. That was a scary face.
Good, I'm glad you were scared. I've done my job. I'm not as scary as Miss Mahoney, but I can just
Mahoney's not that. Miss Mahoney's not scary.
yeah, just let her think she is, because she thinks she's scary. So just let her think. Okay, so going around the circle, the first one you would get to is pi over 6, and then pi over 4, and then pi over 3, and your thumb is pi over 2.
Yeah.
Okay, so far so good? Make sense? All right, so if I want to figure out the sine, cosine, and even tangent of one of those angles, what I do is I put down the finger that represents that angle, and then it basically ends up creating the ordered pair. So the finger I put down is my comma, which means that the stuff to the left of the comma is the x-coordinate and is going to tell me what my cosine should be. The stuff to the right of the comma is my y-coordinate and is going to tell me what my sine should be. And the way we get it is by taking the square root of the number of fingers over 2.
My favorite trick.
Okay? So, we're talking about a reference angle of pi over 3. The beauty of reference angles is they're all first quadrant angles. Right? So once I get the reference angle, I can take out my fingers. Which finger should I put down for pi over 3? Index finger, my pointer. So that becomes my comma. Which means this is my x and these are my y. Okay? So for sine, oh, stop it. So for the sine of pi over 3, what would we get? Root 3, the square root of the number of fingers, over 2.
Y2.
Because it's always over 2. Look at your table. Look at,
It's always.
I don't know, look at any of the, let me do this.
It's always.
We didn't
Hang
fill
on,
out the
hang on,
table.
hang on, hang on, hang on, hang on. What do I want to do? I want to add a page. Okay. Special angles. We'll back up a step. Special angles. Do you remember special angles anywhere else? Triangles. Right triangles. We got 45 or 44. Try that again. 45, 45, 90 right triangles. We've got 30, 60, 90 right triangles.
Yep.
Right?
Oh.
In a 45, 45, 90 right triangle, if this one has to be the 90, these two are the 45. And because they're both 45, that means whatever I decide this side is, that side has to be the same.
Yep.
So let's make it simple. Let's make this side 1. That means this side has to be 1. Which means this has to be
2.
So what's the sign of 45? Square root of 2 over 2. Because 1, and it doesn't matter, but let's just say it's this 45. Because the 1 over the square root of 2 would have to be simplified. Make it square root of 2 over 2. Cosine of 45.
2 over 2.
Root 2 over 2. Because now adjacent over hypotenuse is still 1 over square root of 2, which is going to be square root of 2 over 2. Tangent of 45.
1.
Go fill them in. 45. Root 2 over 2. Root 2 over 2. 1. Okay, we got 45? All right, let's go back to our other one, 30, 60, 90. The 30, 60, 90 triangle actually comes from an equilateral triangle. So what do we know about equilateral triangles? All sides are equal, and all angles are equal. And what do all of the angles have to be? 60. Okay, so this time I'm arbitrarily going to pick 2 as my sides. So how do I make it 30, 60, 90? I chop it in half. Okay? So what that means is this angle got chopped in half and is now 30. It also means this side got chopped in half and is now 1. So the triangle I'm actually looking at here is that triangle right there. Okay? So let's go with 30 for a second. From the perspective of the 30-degree angle, what sign?
1/2.
1/2. What's cosine going to be?
Square 3.
Yeah, because if I use Pythagorean, this side's going to have to be a square root of 3 now. So this is square root of 3 over 2. What's tangent going to be?
Square root of 3 over 3.
Because it'd be 1 over square root of 3, which simplifies to square root of 3 over 3. Okay? Now let's do this from the perspective of 60. What's the sign of 60?
Square root of 3 over 2.
What is the cosine of 60? And the tangent of 60?
Square root of
Okay? So notice, these are all the special angles. It's either some multiple of 45, some multiple of 30, or some multiple of 60. And when you look at especially sines and cosines, the only options I have for answers are all something over 2.
Well, that's what.
Okay? So that's why the square root of the number of the fingers over 2 is how we set up our trig. Because it's always going to be over 2. What changes is the numerator, and that's going to be based on my fingers. It's really based on, the height of your opposite side, but, I'm going to do it on my fingers. Okay? So, pi over 3, I had 3 fingers on the right side, which is my y-coordinate, so that means the sine of pi over 3 is going to be square root of 3 over 2. The cosine, let me go back to black here for a second. The cosine of pi over 3 is going to be what? How many fingers do I have on my left side for x? 1. Square root of 1?
Over 2.
1 over 2. 1/2. Okay? And then even tangent can be figured out on my fingers, because if you think about it, y over x now means the same thing as sine over cosine. And when I take sine and divide it by cosine, I end up multiplying by the reciprocal, and since my denominators are always the same, they're always going to cancel out. So my tangents, my tangents are really gotta make sure I write it the right way. The square root of the right side fingers over the square root of the left side fingers. So for tangent, how many fingers do I have on the right? 3, so that's square root of 3. How many fingers do I have on the left? 1, so that's square root of 1. Square root of 3. Well, pi over 3 is the same as 60. What did we just say the tangent of 60 was? What did we just say the cosine of 60 was? What did we just say the sine of 60 was? Oh, come on already.
I've never seen this.
There we go.
Facts. Mind blown everywhere.
Okay? Now, this only gets me the numbers. Okay? I've only done half the job so far. Now, I need the positive or negatives. So that depends on which quadrant I am in. What quadrant is 2 pi over 3 in? The actual angle I'm interested in. 2. What gets to be positive in the second quadrant? Sine.
Students.
So that means cosine and tangent are going to have to be negative. Now I'm done. This is now what 2 pi over 3 is equal to. So, first you need to decide what your reference angle is based on the denominator. Use your fingers or whatever other tricks. Some people have other tricks, that's fine. But figure out what the numbers are based on the reference angle. And then go back to, okay, so what quadrant was my original angle in? How does that affect positives and negatives on my final answer? That'll get you what you need. And the other 3, if you were being asked for cosecant or secant or cotangent, there's just the reciprocal of these. Okay? All right, so let's go back to our table here. We fill in the rest of our acute angles. For pi over 6, what was sine? Pi over 6 was 30, so 1/2. Cosine
Root 3 over 2.
and tangent,
Root 3 over 3.
For 60 or pi over 3, sine was cosine and tangent. So really, that's the 10 you need to know. If you know those 10 like that, you can figure anything else out. Okay? Because everything else either refers back to one of these as the reference angle, or I'm taking reciprocals to get stuff down here. And I can figure out these other ones not only by reference angle, but also by what quadrant I'm in, which one's going to be positive, which is going to be negative. And then you kind of throw these two in just to kind of remind you of like, okay, when I get to things like 0 or pi over 2, then I'm on the axes. And so really it's just about what's the ordered pair. Get the sine and cosine from that. So if you know those 10, you can get all 96. That's what it comes down to. Okay?
Who found out that trick?
I don't know, but it's beautiful. I love it. So, part of what I'm going to ask you to do for Monday, along with whatever remaining problems you have, and we're going to practice a couple in just a minute. But the other thing I'm going to ask you to do is to complete this table. One thing you need to realize, anything on the axis, let's go back to pen here. Oh, that's not on. Pen, there we go. Anything on the axis is not going to have a reference angle. And then technically, first quadrant doesn't have a reference angle because they sort of are their own reference angles. So it's really not until you get beyond first quadrant that you start talking about reference angles. And then I guess this one should technically be crossed out too. Okay? So as you're filling it in, you're going to fill in reference angles for your second, third, and fourth quadrant angles, and then you're going to fill in all of the sines, cosines, tangents, cosecants, fill in the rest of the table. And if you use the patterns, it should take you all of maybe 5 minutes. Okay? All right, so a little bit of practice here to make sure we're on the right track. Go ahead and evaluate those 5 trig expressions. Hey, and it's funny because having worked with teenagers for 26 years, 27 now, I know sometimes teenagers can get a little bit of an attitude. And so I'll hear things when I show them tricks like, oh, that's just so childish. Like, I'm not going to use that because that's just like so elementary, you know? And I'm like, well, you're lost then, because I guarantee you, if you happen to walk in this room while I'm like working on a quiz key or a test key or something, you're going to see me at my desk going. Because it's like, if I don't have to memorize those, like, wipe that off the whiteboard, make room for something else. Like, I don't have to keep storage space in my head for that. I can just go, yeah, okay, I got it. And it even works for the axes. Like if I want to know pi over 2, right? Well, what's now to the right, left of pi over 2? Nothing. What's the square root of nothing? Nothing. What's nothing over 2? Nothing. So what's the cosine of pi over 2? 0. What's over here on the right side? What's the square root of 4?
2.
What's 2 over 2? 1. What's the sine of pi over 2? 1. So it even works on the axes as well. So yeah, you'll see me over there going, I'm 48 years old, and I'm just going, yeah, okay, yeah, oh, okay, I got it.
I think it's funny you had to turn the picture diagonally to get it so that it's how we actually
Yeah. Yeah, and it was amazing when I typed in left hand, like it was hard to find just like palm, seeing the palm and seeing it sort of spread out. There was some like this, and there were some that are like this, you know. There's all these different pictures, but like to find a picture that was just palm out, fingers spread out, it was really hard to find. So had to take that one and then kind of.
Why didn't you just take a picture of your own
Because at the time it was easier to just Yahoo it, search it.
I can't use Google and China. I go big.
Yeah, I was at home, so I had to Yahoo it, not Google it.
Yeah.
One other thing, 'cause I don't know if anybody's doing it in here, but in the A block, some people started being like, okay, so if that's first quadrant, then that's second quadrant, and that's fourth quadrant. which is okay in terms of figuring out what your angle is. Like if it's 11 pi over 6 and you go like this and go, okay, it's this finger that I'm talking about. Listen, because I don't want you to make this mistake. So it's okay in terms of like figuring out which finger do I want for that particular angle. But when you actually go to figure out your sine and your cosine, make sure you're still looking at your palm. Because if you flip it over and say, okay, this is the one I want, and now you go left, right, this starts to look like your left side and this is your right side. But when it's palm up, this is actually your right side. So it's going to mess you up if you keep it turned over. So just make sure that when you go to actually figure out what's my sine and my cosine for that particular angle, that you're always looking at your palm to work it out, okay?
Just hold that this way.
Just leave it there. And then it's like, block it.
Oh, this is your
This is like
so
the
rabbit's
foot of
make it all the
Yeah, when it's up, this is your left, so when you turn it down, it looks like that becomes your right.
What's the
So basically,
So that's why you gotta make sure that,
so
like
you're-
if you're doing
if
this,
you're looking
Oh, wait,
for
right?
pi over 3,
1 should be my cosine and 3 should be my sine, right? So if I turn it upside down, it looks like the 3 is the one that's over on this side of my finger and the 1 is over on this side, so I could mix things up.
What
Isn't that correct?
No, because it was this way, right?
Or just
1 should have been my cosine and 3 should have been my sine. So if I turn it over,
So square
now it
root
looks like
this is
3 is my
square root
cosine and
one.
1's my sine. So it looks
They're
like
both
3's
square
on this
root
side of my finger and 1's on this side of my
Of something
finger.
over
That's not the way
Yeah.
you want it.
So we just have to go from the wrist to the end of the finger, right? So like this should be my
For some
left.
reason, I
And this should be
got
right.
right one and I thought it was square root of what's on top over what's on bottom.
As you look at it, right?
Yeah.
That's where my finger is, that's my left, that's my right.
Yeah, and then I should have been over this to my left.
Yeah.
This is my
This
okay.
becomes my left and this, so it's,
Yeah,
yeah, it could be confusing if you start flipping it over. So if you just know that I always want to look at my palm to figure it out, then it should be
Yes.
consistent.
At first I had to think about it.
Like as long as you know what is what.
I'll say you start from here and go like this.
Yeah, I mean, if you started from here and then here, like, you'd be okay, but not everybody's gonna think that way. Some people are gonna flip it over and go, oh, well, now this looks like it's on the left side and this looks like it's on the right side, and then that'll mix them up. So if you just do it like this, it's less confusing.
This is your left, this is your right, and then if you flip it over, make sure that this is your
Yeah, consider left and right from the bottom rather than from the top, right? Just do it this way. That's what I mean. Just do it that way. It's easier. Alright, let's see what we got. Sine of pi over 4, what's your reference? Pi over 4, right? So which finger?
Middle.
Middle finger would be the one you put down. So what is the sine of pi over 4? Sine of pi over 4 is the square root of 2 over 2. But the sine of pi over 4
Five.
is it going to be positive or negative?
Negative.
Negative, because 5 pi over 4 is in which quadrant? The third. And in the third quadrant we have negatives. So this is going to be negative square root of 2 over 2. Okay, cosine of negative pi over 4. Reference? Sorry, negative pi over 6. The reference is pi over 6. Which quadrant are we in? 4. So our cosine's positive or negative in the fourth quadrant? Positive, excellent. And what is the cosine of pi over 6?
3 over 2.
Square root of 3 over 2.
Square root of 3 over 2.
Don't forget the root around it. It's the root of your fingers over 2.
And it is, yeah, that's positive.
And it's positive because we're in the fourth quadrant, right? Okay, sine of 11 pi over 6. Reference angle?
Pi over 6.
Pi over 6. Quadrant? 4. Sine in the fourth quadrant is?
Negative.
Negative. So I know this answer is going to have to be negative. And what is the sine of pi over 6? 1 half. So the sine of 11 pi over 6 should be negative 1 half.
This finger thing's so easy.
And it's going to be a little cumbersome the first few problems that you get used to, but if you do this and you practice it as you do in your homework and as you get ready for quizzes and tests, it will become really quick. Okay? So the moral of the story is, whatever method it is you're going to use, whether it's your fingers, whether it's something else make sure you're practicing it during the homework so that you get really fluid and really comfortable with it. So when you do problems like this on quizzes or tests, it's just nothing. It's just, yep, okay, it says, yep, okay, yep, got it, yep. It's just really quick. Okay? Tangent 3 pi over 4. Reference?
Pi over 4.
Pi over 4. Quadrant? 2. Tangent in the second quadrant is? Positive or negative? Negative. Tangent of pi over 4.
Root 2 over 2.
Root 2 over root 2. Right?
Yeah.
Root 2 over root 2. It's the same. So my tangent's going to be 1. So negative 1. All right, cosecant of 5 pi over 3. Reference?
Pi over 3.
Pi over 3. Quadrant?
4.
Fourth. But what am I really going to be looking for? Sine. So I think about what's the sine of 5 pi over 3. Okay, so sine in the fourth quadrant is? Negative. And sine of pi over 3 is? Square root of 3 over 2. So now, that means cosecant of 5 pi over 3 has got to be what?
2 root 3 over 3. Negative.
Negative 2 root 3 over 3. Just take the reciprocal of it.
Wait. The sine 11 pi over 6 says.
11 pi over 6, yeah, that's that one. I want sine. That's why.
Yeah.
So square root of 1 is 1. 1 over 2 is 1 half.
Oh, okay, alright. Yeah, I got it.
And it's negative because it's in the fourth quadrant. Alright, got the idea? Okay, so you got homework that's pretty much about all the stuff we've been doing the last 2 days. Hopefully you've done a lot of it already based on the first day. What you're going to see on the second page is a lot of what we did today. All of it's due for Monday. If you have questions, mark them as you go. We'll deal with questions on Monday before we move on.
You're gonna talk about why the reference angle
Oh,
can be
okay,
used-
so say your question again.
Why can the reference angle be used to fine.
why is that
Okay.
Very conscious of the, yeah, why is it the same?
I kind of
Where
want to
was
keep
that
it to
one?
the
Right
just works
here.
level.
Okay, so here's why we can use it. If I were to create the same triangle over here using the reference angle, so this angle is the same right there now, right?
Yeah.
Okay. My distance up and down here is the same here. Okay. My distance this way is the same this way. So in terms of the ratios, my ratios are going to be the same as what they were over here.
That actually makes some sense.
Okay? So it's all about y now, right? Y is sine. So the y of this in relationship to the reference is the same as what the y, the height is here in relationship to that. So y is y, right? And y is sine now. X is x is cosine now.
So it just
So
stays the
that's
same.
why you can use the reference to come up with the other one. Because the distances don't change depending on which side of the
Yeah.
See you guys Monday. Have a weekend.
Yeah.